Hello everyone, welcome back. Today we're going to look at question 28 of Paper 1 SPM Physics 2016. Let's take a look at the question together. Diagram 16 shows a Barton's pendulum. Pendulum Q is pushed to oscillate. Remove that. Okay. So pendulum S is found to oscillate with maximum amplitude because. Alright, so before we go to the answers of the question, we first want to understand what natural frequency actually means. Right, so when we talk about Barton's pendulum, we usually refer to natural frequency. So they're saying that when this is forced to oscillate, this is the one that is moved at maximum amplitude. Now let's see why. Alright, so let's give an example of an opera singer and a wine glass. So let's say that the wine glass has a natural frequency of 500 Hertz. So the opera singer is of course going to sing at different frequencies. So she can maybe start at 20 Hertz and then go as high as 2000 Hertz, for example. So what you will notice is that if you actually plot out the graph of frequency against amplitude for the wine glass, okay, you will notice that it's going to look something like this. So you'll notice that there will be a peak. So when the opera singer starts from 20 Hertz and slowly increases, the wine glass would oscillate at a larger amplitude. So it's going to increase in amplitude, then it reaches a peak. Then after that, after she passes a certain frequency, the amplitude of the oscillation will actually start to decrease. So this is actually how all objects behave. So this peak here is actually at 500 Hertz, which is the, sorry about that. Okay, so amplitude 500 Hertz is at the natural frequency. So when the frequency of the opera singer's voice matches the natural frequency of the wine glass would oscillate at maximum amplitude. So when we come to here, the reason why S actually oscillates at maximum amplitude because the driver frequency of pendulum Q is equal to the natural frequency of the pendulum S. Okay, so Q is like the opera singer while S is like the wine glass. So in this case, natural frequency is actually determined by the length of the string that is attached to the pendulum. So let's go through the answers. So A, the natural frequency of pendulum Q is equal to the natural frequency of pendulum S. So this is actually the answer. So they may not necessarily use the word driver frequency, but because Q itself can be a pendulum whereby you oscillate, you push it and it naturally oscillates at its natural frequency. So you can say it is the natural frequency, you can also say it's the driver frequency for pendulum S. So the other answers are incorrect, okay? As in they're not relevant to the question. So answer is A. Thank you for watching.